Alright guys, so here I just want to explain the important points for the implementation of the code of the Diamond program. So the the Diamond program is just trying to, out of the parameter that the user gives of the number of rows that you want for the diamond, then you print using in this case I'm going to use an asterisk. You print a diamond of asterisks. So um, what's important here? Well, you obviously know that for the program to run, you need to define the same name of the class to the name of the file, right? Then you need to declare a main method, and you need to provide an array of arguments as the parameters for this main method. Some of you already know how to use this, some of you don't. This is something that I'm going to explain later on, but for the moment it's not necessary to really understand that part. Now, there is something that I added here, which is a try-catch statement. What's a try-catch statement? A try-catch statement is trying to deal with the problem of runtime errors that you might get when you're running the program, when the user interacts with the program, or when the program itself raises an exception. An exception is just an error in runtime that is caused by, for example, maybe you try to divide a number by 0, or maybe you try to access an array element beyond the length of the array. For example, an array of 4 elements and you try to access element 5. Or you were trying to get an integer from the user and the user entered a character, not an integer. Or any of those problems that you might get when you are working in Java in runtime. You can deal with those using the try catch. So what it's going to do is going to try to execute some instructions, and in case there is a problem, it's going to catch that exception or that problem, and in this case I'm just going to print a message saying, look, you provided an invalid number of rows, because the exception that I'm trying to catch here is I'm going to ask the user to provide me with the number of rows, and if the user enters something like I don't know, like an M or any letter, it's going to reply with this message like, the information you're giving me is not correct because I get an exception. Now, everything that is in the try is what I'm going to try and do, and in the catch is everything that I'm going to do once there is a problem. All right, so that's how you use a try catch. Now, for this program, as you saw in the code in the book, you had there an example for 5 rows only. Well, or not 5 rows, five lines that are then repeated in the opposite direction. And so you would have, in that case, if you type if you use the 5 there, you would have 9 lines for the diamond. So in this case, what I wanted you to do was to ask the user to get input from the user and use that number to print the diamond. In this case, let's say that I enter, I don't know, a 10, then I need to divide the printing of that diamond into 2, the upper part and the lower part. The upper part is going to be first printing a number of spaces, right? And then the corresponding number of stars that I need for that particular row. So since I already know the number of times that I want to do that, that's why I use a for loop. When I don't know how many times I want this to be repeated, it's mandatory to use a while loop, right? Well, some of you might disagree with this because you could say that a for loop and these three conditions are what makes a for loop, but it's the same as a while loop. And you could say that is true, but if you follow the structure of a for loop with these three things here, then a for loop is different to a while loop. But in essence, they are the same. For the moment, I want you to understand that if you have the number, if you already know the number of times that you want to run this code, then what you should do is use a for loop. So this for loop is first, as I said, printing the number of spaces and then printing the number of these characters, the number of asterisks. And I calculate that based on the row number that I am right now. So if I'm in the first row, I would have I would want to print 4 in this. Well, it depends on the number, but let's say that I have a 10. I'm going to have 10 spaces, no, 9 spaces, and then the star. In the second row, I'm going to have 6 spaces, and then three of these guys, right? So if I'm going to give you this code so you can compare to the one that you implemented, and I'm gonna run it right now, and I think I'm in the right path. Yes, I am. So I'm just going to run it for 5. So if I enter 5, since this is going to use an odd number of asterisks, is going to approximate that. So if I use the same, if I run the program and I say 4, it's going to print the same thing, right? But if I print 6, then it's going to increase, right? So it's going to increase every two number of rows. So to get the same result of the book, I can use either 10 or I can use 9, no, 12, sorry, 11, right? So 11 and 10 provide me with the same result. Now, the other thing that I wanted you to do is to try and see what's the order of this algorithm. So, as you know, when we have a loop inside a loop, and that loop depends on the same input, we might get what we call an algorithm of the order of n squared. So this is no exception, right? So we have 2 for loops that have another for loop inside. In this case, is 2 for loops. So this is going, if we do the math for the big O calculation, we're going to see that is the order of n squared, right? Because there are no inner loops inside these for loops. It doesn't matter that we have 2 of this here. This is going to be the order of n, 2 times the order of n, and we're going to have order of n times 2 times the order of n, which is going to be in the order of n squared. And the same for this one, so it's going to be something like 4n squared, so it doesn't matter, it's the order of n squared. So if you get to the same conclusion, good. And let's see what happens when I run this for a larger number. So I run this for 10 and it takes nothing. If I run it for 50, it takes nothing. But what if I run it for 100? Oh, it takes nothing. But if I run it for 1000, well, it takes a little longer, right? And what happens if I run it for 10,000? Since this is printing things to the screen, this is going to take longer than just an instruction for making a calculation like 1 plus 2. So the print to screen command that we use in Java takes a lot longer than the, for example, add 1 plus 1, because we are using the video card. I mean, well, not the video card, but we are using other instances of the operating system, like the system output buffer, which takes a lot longer than just adding two numbers, right? And so what I wanted you to do is to check how long it takes. Now my computer is starting the fan on, so I think 10,000 is quite a bit for this computer. So I'm gonna stop it right there. Let's do just, I don't know, we had 1,000. Let's try 2,000 to see what happens. Oh wait, sorry. So by increasing it double, it takes more than double the time of 1,000. So as you can see, the complexity of this algorithm, it is exponential. So there you go. Maybe it's better to try, I mean, you can try 1,000, 2,000, 3,000 and see what's the time that it takes, and you are going to see that it's a very high slope curve. Alright guys, I think that's enough for this video. Please check the code and compare it to your code and see if we had the similar ideas or the same idea and exactly the same code. I don't think so, but what I wanted you to know is how to calculate the order of the loops, and to see how that is important when you're defining your algorithms. Alright guys, take care, bye bye.